Hey everyone, hope you've had a really good Anzac Day, and to all the troops any troops out there who are watching or who've served previously, thank you very much for your service. I hope you had a great Australia Day as well. Alright, so it's a little bit annoying. We've got some high cloud here at the observatory, so even though it seems to be, from reports of people in the chat, that it's nice and clear, it's a little bit cloudy up here. So, but I have checked the weather reports for next Saturday and it's supposed to be clear. So I need everyone to pray and promise to stop anyone doing rain dances for Saturday, okay? Really need to do that, but we got a really good day on Tuesday, so I was able to go out and get some really nice shots as well. So we're gonna make it's gonna be, we've got some really nice stuff to show you as well for tonight, even though we've got some cloud here. So if you notice, we've got a chat down in the bottom left here. That's our Discord channel. If you want to join and ask stuff during the live feed, go down to the description there, and you'll be able to click on that link to join, and you'll be able to ask questions. You might have to set up an account if it's your first time here. But we've also got links down there for our Facebook, Twitter, and Instagram as well, so you can keep up to date with what's happening in astronomy. And we've also got our Patreon account there if you want to help us out. The observatory is run by volunteers, so we're trying to keep the observatory alive, and we're also trying to help you out in these times, trying to entertain you as well. So tonight we're going to start in the northern hemisphere. So we've just having a look out the night sky. We had a crescent moon tonight, so it's 2 days old. So definitely next week one of the targets will be a moon. But while we've still got dark skies, we're going to show you a galaxy, or a set of galaxies actually. So where we're looking tonight is at the heel of Leo. So for people who are watching this, they might be going, it's upside down. Yep, that's because we're in the southern hemisphere. So a lot of these constellations will look upside down for northern hemisphere people, but yeah, it's okay. We can still see what it looks like. But we're actually going to start off here in the heel, and we're going to look right about here. It's called the Leo Triplet, and if we zoom in, we get these nice three little galaxies. So this one here is called M66 after Messier. This one here is called M65, and this one here is called NGC 3628, and but also it's called the Hamburger Galaxy. So there's actually a few galaxies that we can call hamburgers because we're seeing them side on. And so these three galaxies are actually interacting with each other. They're gravitationally bound to each other. And the M65 and M66 are situated so that we can actually see the spirals. With NGC 3628, we're seeing it edge on. And through the telescope on Tuesday, this is what we were able to see. So this was actually taken from our ED80 telescope that's on top of the Meade 14 telescope, the Meade LX200 14-inch telescope we've got. So we have a telescope on top of a telescope, which is pretty cool. So the ED80 allows you to do a little bit more wide field view, where the 14-inch telescope, you can only really get these two in at the same time. And so they're about 35 million light years away from us. M65 and M66 is about 160,000 light years apart, and then these two are about 300,000 light years away from NGC 3628. But M66 is the largest of the three, and that's about 95,000 light years across. So it's very, very similar to our Milky Way's galaxy. And they were both M66 and M65 were found by Charles Messier, the Frenchman who's created the Messier catalogue, and they were discovered in 1780. There's NGC 3628 was actually discovered by William Herschel 4 years later in 1784. The NGC 3628, or we'll just say the Hamburger galaxy from now on, is slightly warped due to gravitational impact from the wider galaxy cluster. There is some thought that there had been some interaction between M66 and the Hamburger galaxy previously, when they got to about 800 million light years away from each other. They got about 80,000 light years away from each other about 800 million years ago, and that stirred up a lot. Stirred up a lot of younger stars being formed in what's called a starburst. We can notice that while M65 doesn't have a lot of new stars, they're quite old stars, we're actually seeing here in M66 and the Hamburger that there's actually quite a lot of new stars. So there had to be a moment in time and studying where the momentum of those galaxies, we can see that those two galaxies have had a close encounter, which their gravity would have then stirred the dust and gas in the galaxies to form stars. And we have over the past 50 years, we've actually seen 5 supernovas in M66 as well, which is actually a little bit more than what normal galaxies would show. And it's over a century, a galaxy would get about 2 to 3 supernovas a year. So 5 in 50 years is bumping above average. And our galaxy, we still haven't seen a supernova in our galaxy for 400 years. So that's pretty unusual. It's not actually part of what's called the Leo cluster. So the Leo cluster is a large group of galaxies about 330 million light years away from us, and it contains about 100 galaxies as well. The collections of galaxies are quite common for the universe. And you get these things called superclusters. So when we look towards, actually you can do this right now if you're in Perth. If you go out after this live stream and have a look in the northeast, you'll see a really bright star, and that's called Speaker. I actually can show you right now. So we have here Virgo, quite close to where we're looking, and in Virgo there is the Virgo supercluster, and this is a group of over a couple of hundred galaxies, and they're all gravitationally bound to each other. So we do see throughout the night sky groupings of galaxies, and we can even see galaxies that have interacted. And so what we'll do now is we'll then go to a lovely little nebula called Hubble's Variable Double. So we'll type in, so its NGC number, its new general catalogue number is NGC 2261, and we can zoom right there. And as we zoom in, it's in what's called the Monoceros, or the Unicorn constellation, and it's just to the right of Orion. So you can see there's Betelgeuse we've got Gemini, the twins. You can see Pollux and Castor, which are the two really bright stars in the night sky that make up Gemini. So halfway, just a little bit more towards Betelgeuse and slightly up, is where the Hubble's variable nebula is. And what we can see when we take it through a telescope is this. And it looks like a comet, but it's actually a variable nebula. And what a variable nebula is it's in a reflection nebula, so it's only being lit up by the light from a star or stars, and that brightness changes, is because of changes in the star or dust around it, the star, and it causes the brightness of the nebula to change over a period of time. This nebula is actually illuminated by a star called R Monocerotis, and we can't actually see it. You can just see it in the bright spot here, but it's actually lighting up a lot of the dust and gas around it, and that's why you see this big bulge. It's 2,500 light years away from us, and it's about 1.1 light year across. The nebula itself is about 300,000 years old, and the shape and brightness slowly changes over a period of about a couple of weeks to months as well. You can actually see this right in this little video here. So this is taken over 6 months. So you can see that what they think is happening here is that there is dust moving around the star, and that's causing temporary shadows to actually appear on the actual clouds that are further out as well. Now they think that is one possible reason why we see it changing. It could actually be that there's radiation coming off that star, and it's causing some of the changes causing the dust to move around a little bit. Now, R Monos is actually a T-Tauri star, which is what is a class of variable star that's under the age of 10 million years old. So think of this as, say, 1, 2 or 3 years old for a normal child. Think of this for this star. And so they're a pre-main sequence star. So when we talk about a main sequence star like our Sun, when we have stars that are made up into different, we catalogue them into different sections. So we have dwarf stars, which are small, really economical stars. Then we have our star, which is called a main sequence. And then we have giant stars that are coming towards the end of their life, and supergiant stars as well. So they're really big stars. Now, when we catalogue them using their light, and we can actually put them into a graph. It's called a Hertzsprung-Russell diagram, and what you'll get to see is that you get a patch of stars close to the bottom left of the graph, and then you have this main sequence going from the from the bottom right all the way to the top left, and that's the progression of most normal stars. And then as they get older and older, they progress through the line, and then they jump across to the giant phase at the end of their life. So we're looking at at a star that is actually not even on the main sequence line yet. They usually happen to rotate very quickly, so 1 to 12 days, and that is compared to our Sun, which takes about a month to rotate. And they're very active, and their variableness is very changing all the time as well. So that's why you're seeing so much changing in this nebula over 6 months in this little video that's just looping over and over. So it was actually discovered by William Herschel in 1783, and it was actually it has the honour of being imaged as from the Palomar Observatory's Hubble Telescope for its very first light by Edward Hubble in the 26th of January 1949. And that's where it gets its name, from Edward Hubble. Same person that the Hubble Telescope's named after, and what he's really famous for is realizing that some of these nebulas that we thought, like the Great Andromeda Nebula, aren't actually nebulas. They're galaxies that are far away, and he actually found out that the universe is expanding as well. And so this Hubble had actually studied the nebula previously at the Yates and Mount Wilson Observatory, and so he had different he had shots from different periods of time. So he had taken photographic plates, which are glass plates. Some can be quite large, some can be square. We've got about 28,000 glass plates here at the observatory for back when we were doing glass plates in the early history of the observatory. And so they'd all been taken with telescopes around 24 inches, and they were both reflecting telescopes. So he had plates from 1949, from 1916, and he also had the plates from 1908 from an American astronomer called F.C. Jordan. And this allowed Hubble to actually use a blink comparer to actually go in between the plates and see these changes of the nebula over a period of time. And it's also been taken Hubble Space Telescope's actually taken a photo of this in 1999. So it's nice. It's a little nice one. It's unfortunately it's a little small to see during through a telescope with your eye. You have to have really good telescopes, say our 30-inch telescope, and you need to go quite far out of Perth to get a good image of it, because just so that you can actually see what's actually happening. But it is a nice one to do some astrophotography on and see it progress overnight. So what we'll do after this is we'll go and see another lovely globular cluster. Now, this is one of my favorite objects. It's called 47 Tucana, and it's not really a great time to see it because it's very low to the horizon in the early evening, but it is circumpolar. So if you want to get up, if you're up early, if you've got a telescope or even binoculars, you can actually see this with the naked eye. You look for this small Magellanite cloud, and it's only just a couple of degrees off, and it's right here. So we're looking directly south, and it's at the moment it's quite low. We have to give up on it. We give up stuff about 30 degrees above, about 15 degrees above the horizon in the south, but normally we have a general rule. We don't show stuff below 30 degrees just because it's getting into a little bit more atmosphere. Stuff when it's at its zenith, when it's quite high, you can actually see it's at its best. When it's low on the horizon, that light's got to go through a lot more atmosphere to get into your eyes, and so there's a little bit more distortion. So that's why, thankfully, on the opposite side we have on the opposite side around here we have, actually there it is, we have Omega Centauri. So when we do have to give up on 47 Tucana, we have Omega Centauri, which is the biggest globular cluster around the Milky Way. We have that to give us another globular cluster to show on a night sky tour. But we'll progress forward, and this is what it looks like. Now this is the globular cluster. So think of this as a old folks home. They're very old stars. They're about 12 billion years old, but they are still fairly active with stars. It's the second biggest and the second brightest globular cluster in the southern hemisphere, or in both hemispheres. It's circumpolar to the southern hemisphere, so you can only see it from the southern hemisphere. And so it's 16,000 light years away from us. It's about 16 degrees below the galactical disk of our galaxy, and it's 120 light years across. It's located in the constellation Toucan, or the Tucana. So when you get down to the southern hemisphere, there are going to be some interesting constellations that you'll find out. Just because you don't have the Greek mythology or that they have behind. So we have it's a naked eye object. So even here at the observatory, even though we've got some light pollution, you can still point it out. And it's mostly made up of population 2 stars. So these are stars that are they've got hydrogen. They're mostly hydrogen and helium, but they do have a little bit of oxygen and carbon as well. You'll find we've actually done studies here where they've looked for planets, but they haven't been able to find them. And the original thought was that maybe because it's so crowded, particularly in the core, that there's just not enough. It's too cramped for planets to form. But they've done studies also in the outer regions, and out of there is they haven't even been able to find planets out there. So the thinking is that they have that there's just not enough material like the carbon, oxygen, iron, that all the building blocks for terrestrial planets and other elements to make the gas giants as well, which is really a shame, because if you put Earth directly into the center of that cluster, you wouldn't have nighttime. It's so bright out there and so bright in there, so you just experience daytime all the time. And but it would pretty interesting to see a night sky where you'd have your star, plus you'd have quite large circles from other stars as well. There was some thought previously that some of these that most globular clusters were maybe just were dwarf galaxies that had been gobbled up by their parent galaxy. But that's they're starting to find the case that maybe in most cases, apart from Omega Centauri, that's not going to be the case. It's Omega Centauri, they still believe, might actually be a dwarf galaxy that's had all its dust and gas stolen away by the Milky Way. But in the case of 47 Tuc, as we call it, it is that it would have been an associated cloud forming above the before our galaxy, as our galaxy was forming as well. We found that there's about 20 millisecond pulsars. Now these are neutron stars that are rotating hundreds of times a second. So when you have a star that's about 8 to 15 times the mass of our sun, you get a case where when the star dies in a supernova, it doesn't have enough crushing power to form that star into a black hole, or what we call a stellar mass black hole. We have so you have an object that's been crushed. The core of the star has been crushed, and to about 20 kilometers or so. So you could fit something like this, a neutron star, in this, within a city. But because you've taken a core that's a couple of hundred million, about a upper range of about 150 million kilometers, and you've just crushed it into 20 kilometers. What you've done is you've taken all the atoms within that star. So you've got all the hydrogen, helium, oxygen, carbon, nitrogen, silicon, and even and as I said before, a little bit of iron. And you've squeezed that down, and so you've got your atom where you have the proton and neutron in the center, and then you've got the electron orbiting around it. Well, you've squeezed the neutrons and the protons into neutrons, and so you have an object that's basically just full of neutrons. And while the temperature is slowly dropping down, just the rubbing of those neutrons next to each other are causing some heat and preventing just a sudden cooling. It'll just gradually cool over time. But a pulsar is one of these neutron stars, and it actually keeps the rotational momentum of the star when it was massive. But now that it's only 20 light years or 20 kilometers across, it's spinning very, very fast. And they are incredibly strange. The physics gets very, very interesting, and it is something that we're starting to just be able to understand. In the next 50 years, it will be quite interesting to see what the research is happening, because they're now, you can actually get mountains on these, and when we call them mountains, they're only about a centimeter across, they're centimeter high, because the crushing power of this is so much. A teaspoon of material would weigh Mount Everest. That's how heavy the stuff is. And there's also in this star cluster things called blue stragglers, and again we kind of know what's happening here, but there's still different ways how we think this could be happening. So we call them blue stragglers because they're on the main sequence, but all of a sudden they've moved away from the main sequence, and they've got hotter. Now, there's two reasons that we think at the moment why this has happened. One is that they've merged with another star, or they've stolen mass from another star or another object, and that has caused the star to cause its temperature to rise. So it is quite interesting what is going on here. We have about 160 globular clusters above and below the galactical disk. Some of them actually travel through the disk, like M4, which I showed you last week. If you haven't seen that, go onto our YouTube channel and you'll be able to see it there as well. Oh, Troy, don't spoil my little special surprise for you guys. Yes, it is. It's not only Anzac Day, but it is also the 30th anniversary of Hubble being launched as well. So I've got a little bit of surprise for you guys at the end. So hopefully you'll stay for the ending. Now, one other thing with this before we change is that in 2017, they actually have, they thought they might have found a black hole. Now, further research has called this into question, but they have the research in February 2017 they said they detected a black hole in the center by looking at some of the motions of these pulsars as well. So the next object we shall go and have a look at is called the Southern Beehive cluster. So we'll go through, and this is another object that can only be shown in the southern hemisphere. So this one, and this is the night sky as it is, at the moment. So we can see it's called NGC 2516. And it's in what's called the Carina constellation. So we can see here that we have this big ship that looks like a Greek-Roman ship. And so this used to be called the Argo Navis constellation, and it was named after the ship that Jason and the Argonauts sailed on to try and find the Golden Fleece. In 1920, when they were doing the actual modern constellations, so they actually broke this up because they thought it was a little bit too large. So they broke it up into the constellation Puppis, the stern, the Vela, the sail, and then the Carina was the rest of the ship. And it's right here in the middle of the ship. Now, the reason it's called the Southern Beehive Cluster is because it looks a little bit like the Beehive Cluster, which is called M44 and is also visible in the Northern Hemisphere. It's about 1,300 light years away from us, and it's about 10 light years across, and contains about 100 stars or so. They're about, say, teenage age. They're about 150 million years old for stars, and they were first found in 1752 by Nicholas Louis de la Carre, and it is a naked eye object, so you can actually see this with a good pair. It's a good binoculars object as well. It is also known as the Diamond Cluster, the Fishes Cluster, and also the Sprinters Cluster. And it's also designated C96 in the Cadwell catalogue, which was compiled by Sir Patrick Moore. Sir Patrick Moore is a very, very famous astronomer and also science communicator. He used to do the sky at night for the BBC, and it is an experience to watch him. He's a very, very interesting and funny man, and he has a real passion for astronomy, and you see it when in the old broadcasts. And the reason he actually used Cadwell is that his surname is Cadwell Moore, but because Messier had already taken the name, or had already created a catalogue starting with M, he couldn't use M for just Patrick Moore, so he called it the Cadwell. So all his catalogue of stars and stellar objects are C96 or C100, C50, something like that. And so a lot of these names have been given to this cluster because it is so clear and it's easy to see even without a telescope. It is circumpolar for Perth and for the Southern Hemisphere. It's not visible past 33 degrees north. So this means all of the UK, Europe, north of Europe, of the Mediterranean, and northern, the United States wouldn't be able to see this cluster. So it is a really nice little cluster. What we're seeing here is, we just had a look at the globular cluster. So this was, say, an old folks home, active retirement village. This is a kindergarten or primary school for stars. They're very, very young. They've just been formed from a nebula, and so all the dust and gas has been used from that nebula to form stars, and the radiation coming off these stars, which is called a solar wind, has blown away the rest of the dust, and they're just loosely orbiting around each other. And so you're getting to see stars that are, they're just loosely orbiting around, and then over the next couple of hundred million years, they'll kick themselves off and they'll go off in their own way and orbit around the Milky Way galaxy. This is how our sun would have formed, and just recently they've found another star cluster that has the same chemical makeup of these stars and in the constellation Ophiuchus. And so they think maybe these two star clusters here have actually formed from the same molecular cloud, from the same nebula as well. Troy, beforehand you asked if we've ever done work with SciTech. So we have a group, because we're so far across from the east coast of Australia, we actually have an umbrella group where we all get together for the astronomy, the WA astronomy groups, and we call it Astronomy WA. So we come together to work, come together and chat, see how we're going. It allows us to organise events if we like Astrofest, which we usually hold March or February. So this year was February the 29th. Next year it's going to be February 20th, I believe it is. It's based off when the first quarter moon was. Dragon, unfortunately, we've got a bit of cloud here, so while we actually had the telescope set up, unfortunately we couldn't, the cloud was interrupting our view. Troy, didn't the other Sky Masters? Yes, so you might notice over the next couple of weeks, you can actually see where, if you go to heavens-above, and .com, and you'll be able to get a free account. You put your location in, and you'll get to see where when the International Space Station, Hubble Telescope, and also Elon Musk or SpaceX's Starlink satellites will fly over. So we had a launch during I believe it was Tuesday, Wednesday night. And so there'll be about 60 satellites trying to get into orbit over the next couple of weeks. So if you do go outside and it's a clear night and you see a train of bright dots moving across the sky, that's a group of these Starlink satellites. It is quite beautiful to see, but it is one of the annoyances for astronomers because they can get in the view of their research. And but it does, just over this couple of weeks, SpaceX are working with astronomers to brighten, to try to reduce how much light they reflect. But it's one of the things, even if you paint it black, it will still reflect sunlight, but you'll also toast your satellite as well, because that black paint will absorb the heat more than reflect it. But yeah, so if you go to heavens-above.com and you'll be able to have a look and see. It's pretty amazing to see the International Space Station. It can get really, really bright. So when you see it magnitude -3 or 2, it's going to be very, very bright to see. And but it's one of the things you have to tick off, and it can get kids into astronomy as well. My dad took me outside when it was 95, when I was living in Northern in West Australia, and we got to see the Space Shuttle Columbia fly over, and that got me into astronomy. All right, so now that surprise I was going to talk to you guys about. All right, so Troy let it slip, but in the chat here, but it is the 30th anniversary of the launch of Hubble, and NASA released, or NASA and the European Space Agency released a very special image for its 30th anniversary, and this is it here. Now you're looking at what's called NGC 2014, or it's nicknamed the Cosmic Reef, and they call it the Cosmic Reef because it looks a little bit like a cosmic version of the undersea world. The red nebula is NGC 2014, and that's supposed to represent the coral reef and floating in the vast sea of stars. I love how they word these things. It's located in the Large Magellanic Cloud, so this is not even in our own galaxy. It's in the Large Magellanic Cloud, which is a dwarf galaxy or a satellite galaxy that's orbiting around our galaxy. And so it's about 163,000 light years away from us, and it contains a cluster of really hot stars. So you can see all these stars here, and also in here, and there are about 10 or 20 of them, and they're more massive than our sun. And the radiation coming off these new stars are stripping the electrons, so the outer part of the atom, and from the atom, in the surrounding hydrogen gas. So you can see where the redness here, and that's causing the hydrogen gas to ionize and glow, and so that's producing that red glow. When you see hydrogen, it will usually glow a nice red or purplish color. The blue star, the blue nebula down here, This is called NGC 2020, and it's been created from a solitary mammoth star that's about 200,000 times brighter than our sun. This is called a wolf-rayet star. It is enormous, and it is absolutely spectacular. This is not this material here didn't form this star. This material here has come off the star. These wolf-rayet stars are very short-lived stars. They're very hot. Their surfaces can be more than 10 times as hot as the surface of our sun, and they're very bright, and they're a little bit like an eucalyptus tree. You'll notice for people in the Northern Hemisphere, or you haven't come to Australia before, we've got these trees called eucalyptus trees, and you'll notice that when you see a eucalyptus tree, there's not much around the tree, and that's because it has eucalyptus oil, which we can use to. It's great if you've got a cold and blocked nose. It really unblocks the nose because it's got such a pungent smell. But that oil can get into the soil, and it prevents other stuff from growing. And a wolf-rayet star is very similar. The radiation coming off it blows away a lot of the dust and gas and prevents any star formation around it. But the blue, that blue light, the blue nebula part, has been ejected from the star through a series of eruption events, and these in these massive eruption events, you lose these parts of this material in envelopes of material, so you get this nice ring. And so the different colors have been because of in this case it's more the blue color is more from the actual light of the star. So this here is more being more of a reflection nebula, where this is more of a reflection and an emissions nebula as well. So this is on April 24th, 25th. It was the Hubble Telescope was launched by the Space Shuttle Discovery. It was sent up, and the very first light that they tried to take, they noticed that there was an issue. They were all blurry, and while it was, the actual photos they were getting were better than the ground telescopes that we were having down here. They were just really, they weren't what we were expecting. And what they found out was that when the primary mirror was being polished, it got polished. There was an error polished into it, and that error is about 2% of a human hair. Now, I could pull out a piece of hair, but it would really hurt. So it is incredibly, really small, and because there'd been budget cuts from the government, the US government, they hadn't had money to actually test this on the ground. Had they tested it on the ground, they would have easily picked up this issue, but unfortunately they didn't. They put it up in the sky, and they found that Paul Hubble was short-sighted like me, and so they sent a mission in 1993, and they developed these things that look like different lenses, and so that they could work out how they could get the resolution fixed. So just think of my glasses like that. It wears glasses, and so that it works really well. They had a problem at the end of the mission. They got all the equipment in. They had to be really careful because they had to open the doors of Hubble, go inside, and hover just above the primary mirror, and put in the equipment. They also, one of the solar panels wasn't working properly, so they chucked that away and put a new one on. And at the very end, once they finished putting all the equipment inside, they went to close the doors and they couldn't. And this was a really, really bad case because they had to, if they couldn't close it, that was the end of the space telescope. And I think they ended up basically banging on it they got like a cable and just tightened them in and plugged it in. They actually able to got the doors to close. The blue stars you'll notice down here. Now it's quite a pinkish star. Now I would probably say it's most likely going to be a red giant star, but we do have things called carbon stars. So these are generation 1 stars like our star, and so they do have a bit of they do have metals. So when we say metals, astronomers will call anything that's not hydrogen or helium metals. So it could be a gas and they'll still call it a metal. Now, there's a thing called a carbon star. There's one actually really close to Beta Crucis in the Southern Cross, and they have a little bit more carbon than oxygen in their makeup, and so the star looks like a cherry red. So that is one possibility with this star, that we're seeing what's called a carbon star. But that's also pretty cool to have a look at, because it's not an orange color like we see with red giant stars. It is a cherry red color. But some of the top achievements of Hubble have included measuring the expansion and the acceleration of the universe. Finding black holes are common among galaxies, particularly in the middle. You have this basically all galaxies have a supermassive black hole in the middle, characterizing atmospheres of planets around other stars as well. And these are all accomplishments that have happened because of improvements to the Space Telescope. We've even been able to monitor weather changes on other planets in our solar system. It's a lot easier to predict weather on Saturn and Jupiter because it's just so eccentric. But also being able to look back to 97% of the universe and being able to chronicle its life and its birth and its evolution as well. It's yielded over 1.4 million observations, and its data is being used to do 17,000 peer-reviewed papers. So it is an absolute massive amount of data this space telescope's been able to give, and its longevity has been down to the fact that it's been able to be serviced by 5 space shuttles missions. So they were from 93 all the way through to 2009, and it's even expected to operate into the 2020s as well. So we were very lucky to live in a time where we had these grand space telescopes like Spitzer, Hubble, WISE, and also Chandra X-ray, which is still going as well. We lost Spitzer this year, which is a infrared telescope. Chandra is an X-ray telescope. So we're able to see this amazing universe in all different ways, and so that we can see the universe truly as it is, and we don't have to worry about our atmosphere. So yeah. So all right, guys. So that's the end of the cast. So look, so everyone, you've got some homework to do. Just make sure that we can try and keep next Saturday as clear as possible. It was a little bit strange trying to run back and forth between telescope and here, and it just got to the point where I just had to make a decision, and my desktop was all set up, and it was really annoying. But look, we'll do this all again next Saturday. If you want, join us on Thursday. We're going to be doing a talk on YouTube on Space is Big. I mean, really, really big. So you'll get to see how big the universe is, and how long it would take Daniel Ricciardo to get there in his Formula One car as well. So if you can hit the subscribe page, hit the like page, that would be great, and also press the bell so you can get notified when we do this. That would be great. And if you can follow us on social media, or if you can donate on Patreon, that would be absolutely fantastic. And we hope you really enjoyed this broadcast, and we'll hopefully see you next week. Have a great rest of the weekend, guys.